So welcome again into another video with Code with Akkyaa. In this one, we'll be talking about selection sorting. So what exactly is selection sorting algorithm and why do we even use it? What are the advantages and disadvantages we're going to discuss in this tutorial. First, we'll do the theoreticals, then we'll move on to the practicals. That's how we approach every single algorithm. So welcome back again into the 100 days of DSA mastery. So let's just start with understanding what exactly is selection sorting algorithm. All right. So selection sorting is a straightforward sorting algorithm that works on dividing the entire list into two different parts. So what it does basically is just create an empty list and then there is your given list. So what it basically does is the algorithm goes into the filled list, which is the unsorted list that you have provided, and then it finds the smallest element in that entire list and then take it out and put it into the empty list. So now you have one element up there, which is the smallest one, and then it goes again into the unsorted one and then find the next smallest element and then take it out and put it into the sorted list, then again and again and again, and that's how it works till the point that when your unsorted list, which is your given list, is empty and your new empty list, which is so-called your sorted portion, is totally filled up in a sorted way. So this is basically how it works. All right, so these are the advantages of it: simplicity, memory usage, performance in small list, and stability with modifications, of course. So simplicity, as you understood this is pretty simple to implement and also to understand. Then memory usage, just because it uses in-place sorting, because it's an in-place algorithm. Remember this one. It may be asked in the interview questions. Then performance in small list. It gives a really consistent and also a really fast processing in small list. Then stability. Stable sort with modifications. Like, although selection sort is not stable by default, but it can be modified to maintain a relative order of equal elements. So that is basically an advantages of using this particular algorithm, which is selection sort. All right, so let's just take a brief look at the disadvantages. So basically, the first one is inefficiency, which basically means time complexity, because it is inefficient when it comes to large data sets. Why? Number of comparisons, because it has high number of comparisons, which makes it really slow and really inefficient when it comes to large data sets, right? Then unstable by default, which means it is bad with preserving order. The selection sort is not stable, meaning it may not preserve the relative order of equal elements without modifications. Then the last one is adaptivity, the lack of adaptivity, which basically means that it is non-adaptive. Why? The algorithm does not take advantage of pre-existing order in the list, leading to unnecessary comparisons. Even if the list is partially sorted, it will sort it again. So that makes it inefficient. So now let's just take a small brief look at what exactly are the real world applications of selection sorting algorithm before we move on to the practical stuff. So what are the real world applications of it? The real world applications are not too many because it's not used a lot. It has implementations in some educational softwares, which like I'm not pretty sure about them. So I'm not putting out any name of those education softwares, but I guess because it was into the documentations of those particular softwares. Then it is also used in a lot of different embedded systems, like the firmware updates or something like that. Then it is also used in like small data sets or something. So the real world applications of this particular algorithm is a little lesser than the bubble sort, but it's quite a bit effective and more faster than bubble sort, obviously. So let's just do the practicals of it and see how easy and how fast it is. All right, so we are onto our coding screen right now. Let's just do the code and see how efficient this particular algorithm is. So let's just create selection sort. Our date function is ready. Then let's just take the length of the array. Once we are done with taking the length of the array, store it into the n element. Now what we're going to do is create a loop I in range n, and then what we'll do is assume the minimum is the first element. We'll just assume that the first element is the minimum, like the most smallest element is the first one initially. You have to initialize it. We're not going to initialize it by 0 because we might have negative values into it. So we're going to assume that the first element is the minimum one. Then it will be changed afterwards. So now we are going to test it against the next element. So now when we have the first element as the smallest, then we'll compare it to the next one. So the 0th index will be compared to the first index. If the first index is small, then now our min index is the first index. So it will just keep on swapping and see which is the smallest one, and it will keep swapping until it has nothing more left to swap. Something like that. Pretty simple. It genuinely have really less number of code. Then what we're going to do is swap the found minimum element with the first element. That's as simple as that. As simple as that. So array of I will be swapped with the minimum index of array. All right, so array of I, and that's it. Now we're gonna return the array, and we're done with that. Put out some numbers here. I'm also done with putting out some numbers up here. Let's just print this entire array, selection sort, and just say array. That's it. Now let's just run this program and see how does that work. All right, hit the enter, and now we'll soon have the okay. So what is wrong? I think we made some blunder. Okay, up here it is supposed to be J. Okay, it's just supposed to be J. All right, done. Once we run this program, we'll be able to see the changes, and now you can see it's boom, done. So it is that simple. Selection sorting algorithm is perhaps one of the best and the most simplest algorithms that we use out there. So this was all about selection sorting algorithm. See you in the next one with a next new algorithm. Thanks for watching.